All right, 7.1, Introduction to Hypothesis Testing. So hypothesis test, we're going to study an important technique in inferential statistics called hypothesis testing. A hypothesis test is a process that uses sample statistics to test a claim about the population. So researchers use hypothesis testing to make informed decisions. So one of the first things we're going to do when we're looking at hypothesis testing is we're going to start off by stating a hypothesis. A statement about a population parameter is called a statistical hypothesis. To test a population parameter, you should carefully state a pair of hypotheses, one that represents the claim and the other its complement. When one of these hypotheses is false, the other must be true. So either hypothesis, the null hypothesis, or the alternative hypothesis may represent the original claim. So our definitions, so the first one we have is a null hypothesis. And we're going to use a capital H with a subscript of an O. And it is a statistical hypothesis that contains a statement of equality. And that statement of equality could be an equal sign, it could be greater than or equal to, or it can be less than or equal to. Okay, our second one is the alternative hypothesis. And we use H with a subscript of a lowercase a. Is the complement of the null hypothesis. So if we have equal, the complement is not equal. If we have greater than or equal to, our complement is less than. And our complement of less than or equal to is going to be greater than. So when we look at the null and the alternative hypothesis, H sub 0 or H naught, H sub A, okay, I'm perfectly fine with you just calling them null and alternative. So when we write the null and alternative hypotheses, we translate the claim made about the population parameter from a verbal statement to a mathematical statement. And then we write the complement. So here you have 3 different examples of what those can look like. Okay, these are all using mu, or population mean. We're always going to assume that our population mean mu equals k and examine the sampling distribution on the basis of this assumption. So then we have this table that shows the relationship between possible verbal statements about the parameter mu and the corresponding null and alternative hypotheses. Similar statements can be made to test other population parameters. We can look at if we have a lowercase p, or population parameter. We can also look at our population standard deviation or our population variance. We are going to primarily focus on mu and p. We are not going to look at standard deviation and variance at this time. So, if we wanted to write claims, though, as a mathematical sentence, and then state the null and alternative hypotheses and identify which represents the claim. So a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So we're looking at the proportion, and we're saying that it is 61%. So that is our claim. P equals, we're going to change that to a decimal, so we get 0.61. Then we're going to state our null hypothesis and our alternative hypothesis. Our null hypothesis is going to always have equality, and since our claim P equals 0.61, that's going to slide over and be our null. So the complement of equal is not equal, so the alternative hypothesis is P does not equal 0.61. And then also asks us to identify which represents the claim, and the way we do that is we're literally just going to write claim next to it. Okay, our second problem. A car dealership announces that the mean time for an oil change is less than 15 minutes. So our mean is less than 15 minutes. So if we want to write the claim as a mathematical sentence, it would be mu is less than 15. Okay. Looking at our null and our alternative hypothesis, we want to start off by looking at our claim. Our claim is mu is less than 15. That does not have equality, which means it's going to be the alternative hypothesis. I'm going to go ahead and write claim here with it. And then we want to look at what's the complement for less than. And the complement for less than would be greater than or equal to, which is our null hypothesis. Okay, in our third example, a company advertises that the mean life of its furnaces is more than 18 years. So our claim is going to be that mu is greater than 18. So we're going to write out our null hypothesis and our alternative hypothesis. The null hypothesis, we don't know yet because our claim doesn't have equality, so that's going to be the alternative. The complement of greater than is less than or equal to, which makes our null hypothesis. Okay, so then we're going to look at statistical tests and p-values, and actually we're not going to talk about p-values in this section. So after stating the null and alternative hypotheses and specifying the level of significance, which we'll talk about what that means later, but that is going to be alpha. The next step in a hypothesis test is to obtain a random sample from the population and calculate the sample statistics such as the mean and the standard deviation. The statistics that is compared with the parameter and the null hypothesis is called the test statistic. The type of test used and the sampling distribution are based on the test statistic, and this is a table from your book. Okay. After we find our test statistic, we're able to make a decision and interpret the decision. So to conclude a hypothesis test, you make a decision, interpret that decision, and there are only two possible outcomes to a hypothesis test. Our options are to reject the null hypothesis or to fail to reject the null hypothesis. Failing to reject the null hypothesis does not mean you have accepted the null hypothesis as true. It simply means that there's not enough evidence to reject the null hypothesis. If you want to support a claim, we always want to make sure that we state it so it becomes the alternative hypothesis. If you want to disprove a claim, you state it so that it becomes the null hypothesis. So we have a table that helps us with our interpretations when we're looking at hypothesis testing and interpreting our decision. Okay, so this is going to become extremely important to you. This is going to be the basis of your final answer with every problem we do. So when we are looking at our claim, anytime that your claim is in the null, we are going to either reject the claim. And if it's in the alternative hypothesis, we're going to support the claim. The other thing we're going to look at is our decision. If our decision is to reject, that tells us that there is enough evidence. If we fail to reject, that tells us there is not enough evidence. Okay. So let's say you perform a hypothesis test for each of the following claims. How should you interpret your decision if you reject the null hypothesis or if you fail to reject the null hypothesis? So we're going to start off by just writing out our hypotheses. So our claim is that a university publicizes that the proportion of its students who graduate in 4 years is 8%. So we have our hypotheses, our null and our alternative. So our claim is that our proportion is 82%. Since we have is, we know that that means equals, which is going to be in your null hypothesis. So our P equals 0.82 is our claim. And then our alternative hypothesis is going to be the complement. So P is not equal to 0.82. So if our decision is to reject the null hypothesis, and we'll talk about how to make that decision in our next section of notes. Our interpretation, it's going to start off with some information that you're given in the problem that we don't have, at this point at least. When we reject, that means there is enough evidence and then we look at our claim. Our claim is in our null hypothesis, and since it's in our null, we're going to reject the claim. So there is enough evidence to reject the claim. And then I want you to go ahead and state what that claim is. So the claim that students who graduate in 4 years is 82%. Okay. Now, when we make the decision fail to reject, the null hypothesis, it's almost identical in the interpretation. The only difference when we fail to reject is instead of saying is, we say is not. Okay? So we have the information we haven't been provided with yet, and then there is not enough evidence to reject, and we're rejecting because our claim is in our null hypothesis. So we're rejecting the claim that students who graduate in 4 years is 82%.